No problem. Okay, hello everyone, I'm Karol. And today I'll be covering the topic of the node modules and actually what darkness lies within it, what kind of the monsters are there. As you may trust me, there are some. But first, let me introduce myself. I'm Karol. I'm working here at Trump Network as part of the platform team, where we are making sure together with my colleagues that our platform and our system is working smoothly 24/7. On a private line, I'm the huge fan and enthusiast of the Lovecraft's writing, the way how he storytells the horror-like stories, and at the same time, I'm the passionate tabletop game master, telling and leading the stories for my players in the worlds like Call of Cthulhu, Warhammer, or D&D. And those last 2 points means that I have quite of an experience with monsters themselves. So perhaps that's why a couple of months ago, my team told me to deal with monsters in our own node modules. Perhaps they misunderstood me when I was like bragging about killing the demon in my last D&D session. But whatever. Speaking of node modules, we all heard about them, we all see them, use them every day. And I don't know about you, but I was always haunted and really scared of seeing them in real world, seeing how big of them, how big they are, and that even the smallest application can bucket this whole monstrosity sized of the node modules. So I was scared, but then I just got curious because I could not believe that it's possible in JS that even such simple application ends up with like this 12 gigabytes of dependencies. So I ventured into those darkest depths of the node modules to find out what waits for me there. And I've been really shocked because I found out multiple monsters hiding in each of the corners. The monsters that really like to consume your minds, your sanity, and so on. I survived the face-to-face encounters with those monsters, and right now I can share my findings with you. So you can become one of those sexy bastards, the Ghostbusters of your own. Or if you prefer to use some lightning powers, you can become also the paladin and eradicate those monsters with lightning smites after the presentation. I permit this. But let's first travel to the past when it all first started, to the year 2010. The dawn of Node.js, when the Node.js was first created, as well as the NPM itself. It was the era of so-called nested node modules. The name is basically like this because back then, when you were using the NPM, you would end up with structure which was basically nested. Actually, if you would like to go back in time and see how it did look like back then, you can use in the latest version of NPM, you can use the install strategy equals nested option, and that would basically use this old algorithm for node modules creation in the current NPM version. And what would you see if you would like to install the React and React DOM is this nicely nested structure where this node modules was created within our package, and then just nicely structured for React and React DOM dependencies. And we can also see that the dependencies themselves of the React DOM were also nested. This can be even better seen if we install something more complicated, like React drag and drop components. In this case, we can see even more nesting, actually quadruple one. As we can see, it's going through the React DND, then the core, then Redux, and Babel runtime finally. So it's like nesting for each subsequent packages. As you can see, this nesting algorithm is it's actually that simple, but there's a small catch. Because I've been showing you the example for only one package or one project in our repo. If you would like to make and mess up a little with our repo and make out of it a monorepo and have similar or free packages actually, and install for all of them the React, you can immediately see a small problem that we end up with 3 copies of the exact same dependency. And this, ladies and gentlemen, is the first monster that haunts our node modules, called doppelgängers. What doppelgängers are? Actually, when I was venturing through those node modules, I was able to take the picture out of them here on the left side. It was really dangerous, but I survived. And as you can see, these are really these small, pale, goblin-like monsters that really like to disguise as your favorite packages and then consume favorite snacks, which of course is your own disk space. But joke aside, that's basically just how we call those duplicates of the packages in your Node modules. And as a matter of fact, the bigger your project is, the higher chance you will catch some, because you have the more dependencies that can be duplicated in one way or the another. The biggest pitfall of those doppelgängers is basically they inflate the size of your Node modules, which can reach even to 80%, and we will see this in the future. And the bigger your Node modules is, the slower your install, because you have more files, they are bigger, so you're just limited for your constant throughput of your disk or network or other resources on your instance. And this can actually have the even worse snowball or compounding effect on CI/CD when you can have multiple parallel installations of these Node modules going on at the same time if you're running multiple jobs on the same CI/CD node. At the same time, the bigger your Node modules are, the more bloated your bundles can be. Although I'm not the expert with bundlers, but I've seen some cases where actually this was happening, that bundle was not able to duplicate some packages, and still like these duplicates were shipped in the production bundles, I mean the front-end ones. Last but not least, those packages are no longer singletons. And that may lead to really all kinds of confusing and hard to debug issues, especially if your packages are stateful. If they contain some caches or any stateful logic, then this behavior of these packages may become inconsistent depending which instance you end up calling for some maybe utility library or some other dependency. Similarly, if the package has some kind of the dynamic entity resolution or injection logic, like in Nest.js, you can also harm yourself, because then, depending in which instance of such a library you will register those entities, they might not be discoverable if you call or try to discover them in other instance. And lastly, there are also duplicated type definitions, which again can harm you in your TypeScript builds. But you might say, oh, Karol, I'm not using monorepo, doppelgängers won't harm them. Wrong. And I have proof for this. So let's install and create the empty npm project and install something simple as, say, jest, using this nested strategy. Then run this horrendous one-liner, which basically all it does, it detects all packages installed in your Node modules and count their occurrences. And that's what we get. Over 80 duplicates of some Babel sub-packages, over almost 19 duplicates of Pico colors, or 16 of Semver. A lot of duplicates, as you can see. And all of this making our simple project with just a Jest installation weighing over 200 megabytes, quite a lot. And if you're wondering why those dependencies end up being duplicated, you can use npm ls command and seeing this nicely structured tree explaining all the relationships between packages and see where it comes from. But you might again say, oh, you are doing some outdated nonsense. It was year 2010. We have 2015 now, man. Well, you are sure. You're right, because in 2015, actually the NPM version 3 has been released. And with it, the era of flattened Node modules and hoisting has appeared. And NPM 3 explained this behavior or this approach in its own release notes. I will not read it because on the rehearsals it sounds pretty terrible, but it's quite complicated and vague. So let me explain this in more friendly manner. This is the repo that I've been showing you when explaining the doppelgängers for the first time. What hoisting does in this case, did it break? No, it's fine. It first creates the Node modules folder in the root level of your project, and then puts all of the dependencies there. So in this case, you get those copies of React. And they are deduplicated to a single instance, which is put right there. So we end up with this simpler and smaller structure with just a one instance of React, as it should be. Again, if you'd like to check it out for a little more complicated dependency like Express, which actually has some dependencies on its own, we can see that this hoisting, which I'm just presenting, is also being applied to those transitive dependencies. So actually, we can consider these root level node modules as like the big bag of all dependencies that are being used in your packet in your project, and they are being put there. But it can get a little bit more tricky. Let's assume we have the project with 4 instances of the React, but 3 of them are React 19, one of them is React 18. Well, in this situation, we cannot just simply hoist a single version of React, because we would end up shipping the wrong version to at least one of those packages. So what we can do? Well, it depends on the packet manager. In the NPM, it would hoist the very first discovered version. What I mean by this is when the NPM traverses your project, it basically remembers each version of each library that has been discovered first. In this case, the traversal would first go into package B, which means it would see the React 19 first, and that's what would be hoisted in NPM. But we can play with it a little and break it. Maybe not break it, but show how inconsistent it can be. So let's imagine that then somebody adds a new package to your monorepo called A that goes before the B. What happens? Well, the structure of these node modules then will change. Oh, I see myself. And now the React 18 will be hoisted. So it can become inconsistent when you add the new packages. On the other hand, in Yarn, they are using much simpler approach. They basically hoist the most common version. So they are optimized for disk space saved. That's all. But as you can see, in both cases, hoisting doesn't eliminate the doppelgängers. They are still there. Some of them are deduplicated, and we are safe from them, but they are only scratching the very surface of this problem. So you may ask, is it even good if it's not solving the problem for good? Well, so let's recreate the previous experiment, as we did previously, but this time using the hoisted strategy. So we are again running this monstrosity of the one-liner, and we end up with quite nice. No doppelgängers, almost at all. Only some 4 duplicates of Samver. And by this mean, we get just 30 megabytes of the package. That's whole 86% reduction. So actually, hoisting is not that bad if your project is not that complicated. And you don't have that much of these conflicts of different dependencies. If your project gets bigger, then probably hoisting won't save you that much, because the conflicts will be much more common and not that many versions could be deduplicated. But with the great power comes the great responsibility. The hoisting itself, because it puts all those dependencies in the root level node modules, which can be discovered by any package, actually liberalizes the way how the modules could be resolved. And this awakens yet another dangerous foe, called phantoms. This on the right side, you can see it's a footage from CCTV camera in my home when I was trying to deal with some issues on my company laptop. Those are basically the entities that tries to mimic the friendly beings, help you and making your life easier, but just waiting to strike. But just aside, that are basically the dependencies that are used in your source code, but they are not defined in any package.json. How it may happen is basically you install certain new dependency, the new at all in a whole monorepo, in one package, and then just start using it out of hand in another package without doing anything. Out of the carelessness of certain developer or just being unknown that he needs to add the package.json, in many ways it may happen. And at first, it may sound really handful that you no longer need to worry about package.jsons and maintaining them. That's great, you may say. But well, it may really hunt you in many, many ways, especially if you assume that a given package is defined in a only single place in your repo. Then, if you update its version, it suddenly propagates to your all other packages which are using this dependency silently, and may break your build for all the company you wanted just to upgrade a single package for a single project. Then you're ending up breaking entire company. Similarly, if you remove it, the same thing's happening. Package manager no longer see and can discover this package anywhere, so it will again break all others project at the same in the same way. Or if you really want to be a dick, you can actually define it as a dev dependency. In this way, it actually will be present in your local and testing environments, because there we are installing all dependencies. But when it comes down to the production builds, then usually those dev dependencies are excluded. That means you will be actually shipping this code without those dependencies that are required. So you will build the production. Luckily, they are much easier to be dealt with than doppelgängers, as basically you just need to find them and fix manually by adding them to the package.js. So the life was really grim since 2015, but I may surprise you, but since then there was no any update for the NPM hoisting at all. It's using it for the last 10 years. But then, finally in 2020, the savior we have all been waiting for has come. The true lisan al-gaib of the package managers. It doesn't work. The PNPM, which stands for the Performant Node Package Manager. It was created actually in 2016, so only a year after the NPM announced its hoisting approach, but didn't get much traction until 2021. Which can you see actually on this chart that I prepared, where I scrubbed the information about the package managers used in top 2000 JS and TS repositories on GitHub. You can see right now it's around 20% of the market share, while back in 2021 it was like 1%. What's special about the PNPM is that it's not using any flattened modules, nor the hoisting, but instead it's using the unique strategy based on symlinks. And this way, it actually gets rid of the doppelgängers and phantoms for good, at the same time being faster and more space efficient than its alternatives. In terms of the benchmarks, here we have some data. The one on the right side is actually the official benchmark for PNPM, made by the people behind it. You can see that it's pretty much always a lot faster than NPM, sometimes in par with the yarn, sometimes slower, sometimes faster. But what I prefer to trust is actually the benchmarks from our own monorepo, which we recently migrated to PNPM from yarn. In our case, it allowed us to decrease the install times, for the clear install times without any cache or node modules, from 3 minutes to 1 minute, so it's a huge drop. At the same time, halving our node module size in terms of its own raw gigabyte size, as well as the amount of the files that's within it. But how PNPM does it? So let's see what would happen with our package structure when we would install stuff with the PNPM. So let's start with installing the React 18 for package A. What would happen first is that PNPM creates something called global store or repo scope stored within this root level package in the node modules. But there's a small catch that is it's storing it under the dot file, which actually is not discoverable through node module resolution algorithm. So any package that would land there will not be visible for node. Then we put all those packages there, installing, reminding about the versioning itself as well. So it's not like in the normal node modules where only the name of the package is maintained. No, we also remembering about the version itself. And then, in order to make this package resolvable from other package A in this case, instead of copying those files, dependency files, straight into those node modules, instead we are creating something called symlink, which basically is this kind of the file on our file system that instead of storing its own raw content, points to the another file. And this symlink, in this case, points to this React instance stored in the PNPM store. Then, if you would like to install the React DOM, very similar happen would go on. This React DOM would be put first into our global storage, as well as its own sub-dependency. As you can see, the very own node modules of the React DOM is also structured just like the other package using the symlink. So there's no duplication on this level as well. And then the same what we've seen for the React itself. This React DOM is linked through symlink. Then if you would like to install both packages for B, you would not install anything on the global level. We will only create these symlinks. And lastly, if you would like to install some conflicting package like React 19, there will be no issue at all, because still they will be put into our global store just with different naming, so there will be no name conflicts. And then again, we are linking it. So what are the real benefits from this approach? First, there are no doppelgängers because we are installing every and each package just single time. We are actually doing this in the most space efficient way because we are only installing these dependencies which we need and doing this one exact time. Then there are no phantoms because we don't have any hoisting here. Each package has its own node modules filled with the dependencies that are only defined in its own package.json. So just to end my talk, a few tips from me how you can ditch your hoisting and use symlink approach instead. So first, you should choose your fighter because actually all node package managers currently implement the symlink-based strategy in one way or the another. In case on the NPM, it's called the install strategy linked. It's in experimental stage for 2 last years. I haven't used it, so I cannot really talk much about it, but you can try it. In case of Yarn, it's in the stable release. From my experience, it's okay-ish. Actually, when I was migrating our monorepo to Symlink, I first started with Yarn, but then got pushed back with nasty bugs, so we end up using PNPM itself. And from my own knowledge and experience, for the last couple of months, I think that PNPM is the best choice, the most reliable and configurable, and the most maintained, the mostly active maintained. The second thing that I would advise is to separate tool migration from the linker migration. What I mean by this is that if you decide to, for example, go from Yarn to PNPM, you may first consider moving just your CLI tooling from Yarn to PNPM. So if you're using the hoisting in Yarn, then go to the PNPM with hoisting, and only then take care of the linker migration when you're already within the PNPM ecosystem. It can just save you some additional work, just making this work in parallel instead of doing everything in one big bang release. Yeah, that's what I just said, but you need to watch out, because when you are changing the packet manager, you will need to generate the log file for it from the scratch, and you can silently end up updating tons of dependencies which weren't updated previously. And then, in terms of the strategy migration, you will need to first fix the phantoms and doppelgängers, because if there are any phantoms in your project, and then you migrate it to the PNPM, they will no longer be resolvable. So we need to take care of this first. In case of the doppelgängers, actually I lied to you, because symlinks do most of the work for you, but you may be interested in checking out the do peer dependence option in PNPM, which all it does is taking out the potential problems with peer dependencies out of the picture. And in terms of the fixing phantoms, well, that's a lot of more work, because basically each and single one of those phantoms need to be found out and fixed manually, meaning adding them to the package.json. So this can be a lot of work, but again, I have a couple of tips for you. First, you can check out the dep check tool, which basically what it does, it scans your source code, it imports and comparing them with the content of package.json, so you can check out which packages are missing or actually defined in the package.json while they're not being really used. And this should fix most of your problems. It will just end up with like some edge cases like plugins or packages imported dynamically and so on, which are actually the hardest part of the migration. That might sound really simple, but you can also consider using agentic LLM to automate your work, because the previous part requires a lot of the repetitive work. Just tell the cursor to do it for you. Just give it a few steps what to do step by step, and it really will do the great job for you. And use your own time to tackle more complicated and challenging cases. And one more important thing, if you have a problem with the phantom dependency and you don't know what's going on, always check the upstream package, because you'll be surprised how many of the NPM packages are actually published with once. And I'm not lying. If you check some issues on popular packages, you can see a lot of people annoyance about some dependencies not being defined yet used. So always check this and just compare if the thing that the runtime is complaining about is actually defined in the package JSON of the package. And last, some approach that actually came up on Friday's evening. If you really don't know and you are just lose your mind which package is missing because it's just too vague and those errors are just too unreadable, you can use the bin search. How? Basically, what you can do, if you have a command that is failing and you want to fix it, and you know that the root cause is the phantoms, you can take this command, generate hoisted node modules, sometimes on the site, and then copy this folder somewhere between the root level node modules of PNPM and the package you want to solve. This way, you will make those hoisted node modules discoverable from the node runtime. And now you can do the binary search for the content of these injected node modules you just did. And I believe everybody knows how the bin search works. You basically split it by half, checking the result of your comment. If something changed looking like it's fixed, then perhaps this content that you have in your these injected node modules perhaps are storing this dependency that is missing. And you go on until you find out just a single dependency left in these injected node modules, and this should be the one that you're missing. If you're a little confused, go out and check my own implementation that I did and actually used during the migration, so go ahead. And that would be it from me. Thank you all, and there are also the link for the slides if somebody wants. I probably should generate the QR code, but yeah, thank you.
My question, did you try to use ban as a package manager? Because it's, from my experience, also pretty nice.
I was expecting this question, so I prepared. Actually, ban and also Dino, because it's a little bit a similar topic, it's something else than the packet managers. That's a different runtime. You need to remember this. Because Node is its own runtime, Dino and ban is its own runtime. But it's also the packet manager itself. So it's a little bit different topic. And actually, from what I know, for example, the Node documents real well how it discovers and resolves all those Node modules. You can go out in the documentations for ASM and CommonJS modules. There are these step-by-step instructions how it's being done. It's not documented for ban, so I don't know how they do it. So this gives me a little bit of fear of moving out, because it makes things that are not compatible. But from what I know, how the ban achieves like those duplicated packages, because it does something similar as the PNPM. So it has this global store, but instead of doing symlinks, it's actually doing those symlinks in the runtime. So instead of storing them in your node modules, it's discovering them during the runtime. So I may assume that some of this work may be put into the runtime, and it may slow down a little bit of application. I don't know. But that's my insight of how the ban works. Did I consider moving it? Not really, because I thought that it's a little bit too much work and too much of the paradigm shift. But maybe we will do in the future.
You have something more? Just Just want to mention that ban can work just a package manager and without this runtime things that you mentioned, just create like NPM and etc. So actually you can use it without any.
Actually, I didn't actually know this. I thought it's the other way around, that you can actually use the Node packet managers with ban, but I didn't know about the other way around, but it's good to know. So thanks a lot.
Perfect. Do we have any more questions that are actual questions?
So I use the newest version of PNPM, and I think it does something also a little bit different to
hard links or hard links or not?
No, I think it combines the names of different packages, and this is how, like, you end up with, like, you know, weird names of packages in Node modules. And do you know why it does it and,
Yep.
and so on?
Actually, I've omitted this part on our presentation because I consider this would just be a little bit too long. What I just described is basically the side effects of pure dependencies. I'm not sure if you know what's that. The pure dependency is basically the dependency of the package that the package says that I don't want to install it by my own, but if you want to install me, you should have it already installed. It's usually used when you're implementing the plugins that should like monkey patch or hotload certain stuff. And those stuff that you're seeing in the PNPM, those additional packages, are basically definition of those pure dependencies that are being shipped with this version of dependency. But actually, you can mostly get rid of this problem because those pure dependencies actually can generate the doppelgängers if the pure dependencies versions mismatch. But you can get rid of it with this function that I presented previously. The do pure dependence. If you use it, then you will always, or mostly always, end up with just a single version of each package. Nonetheless, the pure dependencies are.
Thank you. I'm afraid we don't have time for more questions. I'm sorry.
Warsaw.